The sine, cosine, and tangent ratios can be used to help us solve for missing sides and missing angles in right-angled triangles. Instead of saying sine, cosine, and tan, we usually use the three-letter short forms sin, cos, and tan, which match the letters on your calculator. When you're using a right-angled triangle and you wish to find a missing side or angle, whether you choose sine, cos, or tan depends on what sides you know or want to find in the triangle. Sine is the ratio of opposite divided by hypotenuse. Cosine is the ratio of adjacent divided by hypotenuse. Tan is the ratio of opposite divided by adjacent. And to help me remember what the different ratios are, I use a little short form called SohCahToa. And it's a little easy way of remembering that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Now, we've already talked about the hypotenuse when we did Pythagorean theorem. The hypotenuse is the longest side in the triangle, always located directly across from the 90-degree angle. The opposite and adjacent sides, however, change depending on the angle that you know in the question. If this is the angle that I know in the question, the one across or opposite from that angle is the opposite side, and the one beside the angle is the adjacent side. Adjacent is another word for beside. The hypotenuse is also an adjacent side, but it has its own special name. So the hypotenuse is the longest side. The opposite side is directly across from the angle that you know in the question, and the adjacent is the third side beside the angle that you know or want to find. You'll notice that I've used a Greek letter here. That's not a 0, it's a theta. It's just a Greek letter of the alphabet that is traditionally used for marking angles in diagrams. We're going to try 3 examples using our new ratios. So the first one says solve for x, and I have a triangle with a side of 100, a side of x, and a side that is unlabeled, and I have an angle of 25 degrees and a square showing that this is a 90-degree angle. The 90-degree angle is what tells me that I can use my sine, cos, and tan ratios, as they do not work in non-right angle triangles. The first thing we should do is label our sides. I start with the hypotenuse, as it's the easiest one to find. It's directly across from the 90 degrees on the longest side in the triangle. So that 100 is my hypotenuse. You can write out the full word. I like to just use the letter H. To figure out opposite and adjacent, I need to think about the angle in the question. The angle here is 25. So the one across from the 25 would be the opposite, and that third side beside the angle is the adjacent. To decide which ratio, sine, cos, or tan, that I want to use, I need to look at what information was given in the question. I notice that the hypotenuse is 100 and the adjacent is x, and I notice that there are no markings for the opposite side, which means I do not need to use the opposite side in this question. I have no information about it, and it's not labeled as a side that I want to find, which means I need to choose a ratio that uses A, the adjacent side, and H. If I go back to my SohCahToa, I see that the A and the H are in the cosine ratio. So I'm going to start by writing down my formula. Cosine of the angle, I'm going to use the letter theta for the angle, is equal to the adjacent side divided by the hypotenuse. So cosine of my angle, cosine of 25, equals the adjacent side, which is x, divided by the hypotenuse, which is 100. To solve for x, I need to get it by itself, so I want to find a way to take that 100 to the other side. Since we are currently dividing by 100, we do the opposite and multiply on the other side by 100. So we're going to end up with 100 times cosine of 25. Now, depending on the type of calculator you have, it's going to determine how you're going to type this in. If you have a calculator where you do not see what you type in on the screen, I would start with the 100 times, and then to do cosine of 25, we actually have to put the 25 in first and then press the cosine. Now that's just the answer for cosine of 25. If I want to know 100 times, I need to press equals, which gives me an answer of 90.63 centimeters. To use a calculator where you do see what you type in on the screen, I'm also going to start with the 100 times, but this time I'm actually going to press cosine first and then 25 degrees. And I also end up with the same answer that I had before. To do the next example, I see another right angle triangle, and the question says solve for x. This time I have an angle of 40 degrees and an angle of 90 degrees, which tells me that I can use my SohCahToa or sine, cos, and tan ratios. I have a side of 15 millimeters and a missing side x. The first thing I want to do is I want to label my sides. I start with the hypotenuse. It's across from the 90 degrees, the longest side in the triangle. This is going to be the hypotenuse where side x is. To figure out the opposite and adjacent, I need to focus on the angle. The side directly across from the angle is my opposite, and the third side would be the adjacent. I'm going to look at the information that I have in the question. I notice that I have no information at all for the adjacent side. It's not labeled as a side I want to find, and I don't have any information about it. So we are going to ignore that side and use the hypotenuse and the opposite. If I go back to my SohCahToa, hypotenuse and opposite would be in the ratio sine. So I'm going to write sine of theta is opposite over hypotenuse. Sine of my angle theta, which is 40 degrees, is going to equal opposite 15 divided by hypotenuse, which is x. You'll notice this is a little different from the last question, as the x is in the denominator, whereas in the previous question, the x is in the numerator. The first thing I need to do here is I need to find a way to get the x out of the denominator. So we do the same thing we did last time. We're going to multiply it up to the other side. So I'm going to end up with x times sine of 40. To isolate for x, we need to find a way to take the sine of 40 to the other side. So we're going to do the opposite, and we're going to divide both sides by sine of 40. So x is going to equal 15 divided by sine of 40. To evaluate that on a calculator where you do not see what you type in on the screen, I would start by entering 15 divided by, and then instead of sine 40, we put 40 and then press sine. That is sine of 40, so I need to press equals to get my final answer of 23.34. That 5 is going to push that up to a 4, so 23.34. So x equals approximately 23.34 millimeters. If you have a calculator where you do see what you type in on the screen, we're going to start the same way. We're going to do 15 divided by, and then this time we're going to press sine first and then type in the angle of 40 degrees to get 23.34 millimeters. Our last example is also a right angle triangle. It has a side of 130 centimeters, a side of 80 centimeters, and this time what's missing is that angle there marked theta. So the first thing I want to do is I want to label my sides. So we're going to mark on our opposite, adjacent, and hypotenuse. The hypotenuse is the longest side directly across from that 90-degree angle. So there's the hypotenuse. The opposite is going to be the one across from the angle that we want to find in the question. And then the adjacent is the one beside that angle, or the third side that's left over in the question. I'm going to look at the information I have. I notice that I know nothing about the hypotenuse. I'm not asking to solve for the hypotenuse, and I don't have any information about it. So I'm going to ignore the hypotenuse and find a ratio that uses the opposite and the adjacent. If I look back at my SohCahToa, the O and the A shows up in our tan, OA in tan. So we're going to use the ratio tan. So tan of our angle theta is opposite over adjacent. So tan, well, I don't know, so I'm going to leave it as theta, is opposite 130 divided by the adjacent, which is 80. Now this is a little trickier. In this question, I do want to solve for theta, or we could have made it x. So I need to find a way to get that tan to the other side. It's not tan of a number, it's just a tan all by itself. So to move a tan that's all by itself, we do the inverse tan of both sides. So we're going to end up taking this to the other side by doing tan -1, or the inverse tan of 130 over 80. So theta is going to equal the inverse tan of 130 over 80. Now it's sometimes tricky to remember what to do. A helpful tip is that when we're solving for an angle, that is when we use the inverse tan instead of just dividing like we did in the previous question. So I'm going to evaluate the inverse tan of 130 over 80. If you have a calculator where you do not see what you type in on the screen, then we're going to do the 130 divided by 80 first. So I do 130 divided by 80, and very important that you remember to hit equals to get the number, and then shift tan to do the second tan, which is going to give me 58.39, and this is an angle, so degrees. If you have a calculator where you do see what you type in on the screen, I would start by typing in second and tan, and then make sure there's a bracket. If there isn't one, you need to put one in. 130 divided by 80. Close your bracket, hit equals, and I get the same answer.